Assalamualaikum warahmatullahi wabarakatuh. My name is Nurlana Shahira Al-Adman. My matrix number was 2023 84 64 and 42. Alright, so I will begin this representation by introduce list of content, which is the first one we will say about introduction, and second was about objective, and third method of indoor noise measurement, and then we will present about instrument and stuff involved. Next, discussion of finding, and the last presentation about conclusion. Alright, so let's begin our presentation. I will introduce about this presentation, which is background noise in large spaces. The second one was effects, speech clarity, and student focus. The third, ideal level below 35 dBA on the WHO standard. And the last one was common sources, might be from people talking, air conditioning, traffic, or even equipment noise. Alright, then let's begin our presentation. I will introduce about background noise level and our case study, which is within at Pusat Mahasiswa located in UiTM Terasering Iskandar. This Pusat Mahasiswa UiTM Iskandar often has high foot traffic and open space layout. Also, it's a hub for student activities, discussion, and events. And the last one was it exposed various noise sources, indoor or even outdoor. So next, let's go to the next page. Alright, so we will talk about wall material at this Pusat Mahasiswa. The wall of the Pusat Mahasiswa building are typically constructed using reinforced concrete and clay bricks or cement sand bricks, which are common in institutional buildings across Malaysia. Alright, next I will present about objective of this presentation, which is the first one, to observe the building design and surrounding area of the case study house. The second one, to identify problems related to thermal comfort inside the case study. And the last one, to propose the passive design strategies that can improve the thermal comfort level of the case study building.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Nurul Arisha Shazwani bin Hassan. You can call me Arish. So I will continue with procedure. So first thing first, what we need to do is open all the doors and ceiling fan, because we want to ensure natural ventilation and allow external noise to enter the space without obstruction. So this helps stimulate a real environmental noise condition for accurate measurement. This step allows outside sound like traffic, construction, human activity, because we want to naturally interact with the internal classroom environment. Second, what we do is set date and time for 100 seconds at sound level meter, because we want to program the sound level meter to record noise level for specific duration, ensuring consistency across measurements. Third, what we do is measure 1.2 meters above the ground, because we need to standardize the heat at which sound is measured, because generally it representing the average humid year. So 1.2 meter is general measure, so we use the 1.2 meters. So continue with the next slide. Fourth, what we do is set up the sound level meter in the middle of Pusat Mahasiswa. So we put sound level meter in the middle of Pusat Mahasiswa because we want to place the measure device at an optimal central location for uniform data collection. So fifth, what we do is set the time using stopwatch within 30 minutes, because we want to conduct the sound monitoring session over a 30 minutes duration, which given a better average for noise fluctuation. And lastly, what we do is record the source of the sound purpose, like we use an observation sheet to collect the data. Each time when the sound detect, so we record the time, and we record the type and the source, like footsteps, cars, people talking, or a lot more. So it will cross a reference with the data from the sound level meter to analyze better. So we combine the manual and auto. So that's all for me. I pass with my clients.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya wa mursalin wa ala alihi wa sahbihi ajma'in. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azharuddin Muhammad Izam. Today I would like to present about the noise when we collect the data. For the first, the date is 6th June 2025. At the time from 4:34 p.m. until 4:38 p.m. We can see the value unit is normal. At the 4:30 p.m. we can see the value unit is increased, which is the footstep. Okay, for the 4:42 p.m. to 4:46 p.m. the data will look still normal, and for the 4:48 p.m. the data is increased up, which is the remark is about door opening, because the sound effect is so loud. And for the 4:50 to 4:55 the data is come back to normal. At the 4:56, which is the data increase a little bit, so this is the footstep. So for the 4:58 to 5:08 p.m. all along is normal, and the last for the 5:10 p.m. just people talking. So we go to the next. So the discussion of the finding is about to assess the acoustic environment of the student hall, which is Pusat Mahasiswa. A series of indoor noise measurement were conducted using a precious sound level meter. The instrument employed for the study was a Class 2 digital sound level meter compliant with IEC 61672/1 international standards. This device is widely used in environmental and occupational noise assessment due to its reliable accuracy and suitability for indoor measurement. The meter utilizes an awake frequency filter, which is dBA, which closely mimics the sensitivity of human hearing by filtering out very low and very high frequencies that are less audible to the human ear. So the next is about before starting the measurement, we will test the equipment to check if the measurement noise equipment can use or not. Calibration was also repeated after the completion of the measurement session to confirm the reliability and consistency of the data. The meter was set to fast time waiting mode, allowing it to respond quickly to fluctuating sound level, which is suitable for environment with variable noise such as student hall. To stimulate the average human ear level, the sound level meter was positioned at a height of approximately 1 meter above the floor. This corresponds to the height of a seated or standing person. So after done, we conclude the conclusion. Next we go to the conclusion.
Alright, so here we are at the end of the page of presentation, which is how we conclude all this presentation. Through this study, students and professionals are alike encouraged to engage in lifelong learning, staying updated with climate-responsive architectural practice, sustainable material choice, and passive design strategies, effective information management, including collection, analysis, and application of climate data, is essential for improving indoor comfort and energy efficiency in institutional building. So I think that's all from us. Thank you.